Chapter 8. Function calls. That's what it's all about. Get somebody else to do the work. In this chapter, we examine the way to separate a block of code from the main part of a program. This is a useful thing to do because as programs become larger, the code gets more cumbersome unless it is organized in some manner. When we looked at design in Chapter 5, we considered why it was useful to organize a program. A function is a separate block of code within a program. Beyond organization considerations, it is useful to have functions for other reasons. If you have a task that you need to do repeatedly, then putting that task into a function will save you the problem of repeating that code throughout your program. In order for a function to execute, it needs to be called. We will look at how to call a function and also how to send and retrieve data from a function. In this chapter, what is a function? What needs to be sent into the function? Helpers or parameters? What comes out of a function? Return values. Two kinds of parameters: value, copy parameters, and variable, reference parameters. How to call a function. Inside the main when you make a call. Inside the function when you get called. What is a function and why do we use one? In this chapter, we define function and look at all the programming concepts addressed by them. Functions are separate blocks of code that appear before or after the main section we learned about in Chapter 4. A program will appear separated into blocks. See Figure 8.1. Figure 8.1. A schematic of a program shows a visual representation of each separate block with its name above it. Each block represents a separate block or module with its own code. Functions are a way of organizing a program into a separate blocks to accomplish certain tasks. Imagine that you were writing a program to simulate all the tasks that a calculator could do on a number or a pair of numbers. This program would be ideal for using functions because there are so many separate tasks that need to be programmed. A calculator program would do many different things. Think of all the separate tasks that such a program would execute. Adding two numbers, subtracting two numbers, multiplying two numbers, dividing two numbers, converting an answer to scientific notation, changing from degree to radian measure when working with angles, and so on. Now we could have a large program with a separate function for each of the tasks we listed. See Figure 8.2. Figure 8.2. A schematic of a program is shown with each task as a separate block that would contain code to execute that task. Add, subtract, multiply on top, main below it, then below that, divide, convert to scientific notation, and change to degrees to radians. Using functions on a complex problem allows the program. So using functions on a complex problem allows the programmer to separate her code into separate blocks. By organizing code in this manner, it will be easier for someone else to read and understand her code. Functions are usually isolated in this manner. They appear outside of the main section, and they are called from the main when needed to be executed. Another reason for using a function is to separate code that you will use repeatedly. Example 1. Suppose you write a program to maintain a savings account. The program should print out balances after each transaction. So ideally, you would write a function to print the balance in the savings account. Every time you do something to the account, like make a deposit or a withdrawal, your program calls one of these functions to do the task. Here are 3 functions that would be included in your program: print balance, make a deposit, make a withdrawal. Example 2. Let's say you want to write a program that will keep track of all the music CDs you have. You might want to write a program that allows you to add a new CD to your collection, alphabetizes your list of CDs, and prints all the titles. Here are functions for each of these tasks: add new title, alphabetize list, print all titles. By using functions, you are organizing the program in a way that a reader will be able to better understand what you are doing. Furthermore, your code will be easier to debug because you can find your error in a function more easily than examining an entire program. Along the same lines, you could write functions that access data without changing it. For example, if you write a function that keeps track of how many songs you have on your iPod, you would be useful as well as reusable. You could use the function over and over again every time you update the iPod. What is a function and what does it do? A function in mathematics is a set of directions to manipulate a variable. It is really a collection of operations on a variable. Think of what an adding function would do to 2 numbers like 3 and 5. 3 plus 5 produces 8. We could use other operators with 4 numbers, 3, 2, 18, and 7, to produce a more complex result. 3 plus 2 times 18 minus 7 produces 32. In each case, when using a function, Think of the numbers that go into the function and the answer that comes out of the function. In computer programming terms, a function is a separate body of code that performs some task. Think of it as a machine that has certain instructions to perform, usually on a variable or variables that are being sent into it. Along with doing the instructions posted inside of it, a function machine will probably have some values or variables that come out of it. See Figure 8.3a and 8.3b. Figure 8.3a. A function is shown as a sum machine, where two numbers are sent into it and a sum comes out of it. Figure 8.3b. Another function is shown where four integers are sent into a machine, and as a result, it comes out of it after the operations are performed on them. Example 1. A function finds the square of a number. Notice that in the squaring function, the number to be squared is sent into it, and the result comes out of it. See Figure 8.4. Figure 8.4. One function is shown as simply squaring the number sent in. 5 becomes 25. Example 2. A function prints a message the number of times specified. A function prints a message the number of times it's specified. The number of times specified will be sent into the function, and there will be no values coming out of the function once it has finished. See Figure 8.5. Figure 8.5. The printing function is shown with a number going into it, so that a message can be printed that number of times. Once the function is complete, there is no value coming out of the function. In the last example, we considered a function that has nothing going into it and nothing coming out of it. It is simply a function that does some task for the programmer. An icon or picture drawn by a computer is a separate task that is ideal for a function to do. The programmer does not have to write the code herself to draw the picture she wants. Look at the function draw circle. See Figure 8.6. Figure 8.6. The draw circle function is shown with no value going into it and no value coming out of it. In the previous examples, we spoke of values going into the function and results coming out of them. This is the case most of the time. In the printing function, a value went into the function, 9, but no value came out of the function, since our task was simply to print a message. Compare this function with the squaring one. The squaring function accepts a number and then executes code to produce a squaring of the number. Values, usually stored in variables, both going into and coming out of the function, are two key concepts of function use. It is important that we stop to address all the issues that surround these aspects. How functions interact with the main. When a programmer wishes to go to a function that complete some task, she must write a command to do. When a programmer wishes to go to a function to complete some task, she must find a command to call the function. Before we examine all the details associated with calling functions, let's examine some analogies from everyday life. Calling a function is like calling a friend to help you complete a big project, like painting the interior of a house. You call your friend Ingrid to ask her to paint one room and give her what she needs, the paint, sandpaper, and some brushes to do you the favor. When she is done, she tells you she has finished it. This is an analogy of interacting with a function. In another example, your DVD player is broken and you call a friend, Jack, who is really good at fixing broken DVD players. You call Jack on the phone to ask him if he can help you. He says yes, but that he'll need some tools and a replacement part for the broken part. When Jack is done repairing the machine, he calls you back to say he finished it, and he returns the player to you. Let's review our two examples to see what happened in each situation. By analyzing each case, both from general and specific point of view, we will better understand how function calls work. General: call your friend, call Ingrid. Specific: general, specific. General: give your friend something: sandpaper, brushes, and paint. You are called back. Ingrid calls you to say she finished. You're given something: yes, no. No. General: specific. Call your friend, call Jack. Give your friend something: broken DVD player, replacement part. You are called back. Jack calls you to say he is finished. You're given something: yes, no. Yes. Jack gives you back the player. When Ingrid or Jack did us a favor, they first got something from us to do the work. Then they called us back to say they had finished. In Jack's case, he returned the DVD player to us. In Ingrid's case, she didn't return anything to us, but she accomplished the task: painting the room. Functions work almost the same way. The programmer writes a command that is a call. In the call, she includes variables that the function needs to complete its work. The function executes its code, and after that, the compiler leaves the function to return to the place that called it in order to continue executing the rest of the program. At that point, the compiler may return something to that place, but only if necessary. Let's take 4 examples of functions that we discussed in the previous section and give them names so that we can call them the sum, fun with nums, print, and draw circle functions. General, specific. Call the function, call sum. Give the function something, 2 integers. Compiler goes back. Compiler moves from sum to main. A value is returned, yes or no? Yes, sum returns to an integer. Sum returns an integer. General, specific. Call the function. Call fun with nums. Give the function something, 4 integers. Compiler goes back. Computer moves from fun with nums to main. A value is returned, yes, no? Yes, fun with nums returns an integer. General, specific. Call the function. Call print. Give the function something, an integer. Compiler goes back. Print calls main when done. A value is returned, yes, no? No. Print returns nothing. General, specific. Call the function. Call draw circle. Give the function something, nothing. Compiler goes back. Compiler moves from draw circle to main. A value is returned, yes, no? No. Draw circle returns nothing. Notice that in the last example, the call to draw circle, nothing, was sent in and nothing came out of the function. Both Ingrid and Jack called us back to say they had completed the favor. In the first example, Ingrid simply called us to tell us she had finished the favor. In the second example, Jack called us to tell us he had finished the work and was returning something to us, the DVD player. Functions behave the same way. The compiler will leave the function when it finishes executing its code and go back to the next line of code following the call. We need to know whether a function returns something after executing its code. This is called returning a value. Later in this chapter, we will look at the specifics of how to call a function. For now, it is only important that you understand what is meant by calling a function. Int main, parentheses, open brace, ... Insert call to function here. Compiler will return to this line, ... closing brace. Note, after executing a function, the compiler will return to the part of the program where the call was made. Function name and parameter list. In most languages, a function has a name and a parameter list. The name is used whenever the function is called. Once the function is called, the compiler goes to the function to execute it. Here again, we see another example of controlling the compiler. The compiler leaves the line it is on and goes to the code of the function to execute it. The parameter list is a list of all the variables and their types sent into the functions. It appears to the right of the function name and gives us information about what kind of values we can expect to see sent into this function. Note: think of the word parameter in English. It usually means a boundary or restriction. In computer programming, we are restricting how a function will operate. What is sent into a function through the parameter list determines what the function will produce most of the time. So the parameter list is like the boundaries of the function. Return values. Functions return values usually back to the main, the part of the program where the call was made. They produce a result in the form of some specific type of variable, and that result is sent back to the main function after the called function has been executed. Let's examine the previous example to see which results were sent back. In the first example, where we added 3 plus 5 to get 8, 8, an integer, was the result. In the second example, which involved more operations, 3 plus 2 times 18 minus 7, 32, also an integer, was the result. In the squaring function, where 5 was sent into the function, 25, an integer, was the result. In the last function we examined, the print message function, there was no result, only the actions taken by the function. Let's start by reviewing what each function did. What the function did. Sum, added 2 numbers. Fun with nums, took 4 numbers and performed 3 operations on them. Square, squared a number. Print, printed a message. Now we need to check what type of result is produced. If a function has no result, we use the terms void to indicate that nothing is produced. Function, did it produce a result? What type? Sum, yes, a number. Fun with nums, yes, a number. Square, yes, a number. Print, no, void. Now we need to check to see whether the number produced is an integer or a real. Consider the examples with each function and the values that result from sending different numbers into each function. Example: sent in these numbers, result type. Sum, what the function does, adds the 2 values, 5 plus 12. 5, 12, results in 17, it's an integer. Sum, what the function does, adds the 2 variables, 14 plus 12. Fun with nums, goes to 6, 3, 5, 8, goes to 31, 2. Result, real. 31.2 rather. Result is real. Example: fun with nums. What the function does, adds, multiplies, and subtracts. Multiplication will be first. 6 plus 3 times 5 minus 8. Results in 13. It's an integer. Fun with nums, what the function does, adds, multiplies, and subtracts. Multiplication will be first. 12.4 plus 5 times 8 minus 4.2. 12.4, 8, 4.2 results in 48.2, which is real. Square. What the function does, squares a number. 6 times 6. 6 goes to 36. The result is it's an integer. Square. What the function does, squares a number. 4.2 times 4.2. 4.2 goes to, results in 17.64. It's a real number. Print. What the function does, prints a message 5 times. 5, void, void. The value that is returning after the function is executed will depend on what types are sent into the function and what the function does to those types. Keep in mind that sometimes the same type comes out as it went in. You also want to remember that there are functions that do not produce anything to be sent back to the main section. In this case, we use the term void to indicate that nothing is coming back to the main function. How to write a function heading. A function heading is a line of code that tells the compiler all the important information it needs to know about the function. There are 3 parts to the function heading. First, the return type is listed to tell the compiler that the function will produce an integer. For example, when completed, the term void will signature the compiler that nothing will be returned by the function. The next part of the function heading is the function name. If you are the compiler and you need to call on a function to do work, you need to call it by name. The third part of the function heading is the parameter list, the list of variables and their type sent into the function. Return type, function name, parameter list. Int sum, int x, int y. Double, fun with nums. Double A, int b, int c, int d. Double, square, double x. Void, print, int num times. Combining return types with the names of the function and its parameter list creates Combining return types with the name of the function and its parameter list creates function headings like the following. Int sum, int x, int y. Double, fun with nums, double A, int b, int c, int d. Double, square, double x. Void, print, int num times. Parameters, 2 different types. Parameters, variables sent into functions, are boundaries or restrictions on a function's behavior. When you examine a parameter list, you learn a lot about how a function behaves. Does the function need one integer and one real? Does it require two integers? Or maybe it needs three doubles and one string? By reading a parameter list, you get a sense of the restrictions on the function's work. A parameter list tells us the requirements of the function, much like the analogy of what our friends needed when they did us a favor. Ingrid needed the material to paint the room, and Jack needed a part for the broken DVD player. In addition to the types of variables being an important aspect of parameters sent to a function, there is one other aspect of a parameter list, that is, how the variable is sent into the function. Is it a copy of itself, or itself being sent? The question gives rise to the two different types of parameters. As we examine these two types, notice how each variable gets sent into the function. You will learn about two different kinds of parameters: the value, copy, parameter, and the variable, reference, parameter. Value, copy, parameters. When variables are sent into a functions, they can be sent in two different ways. One way is that the function sees a variable is coming into it, and it generates its own copy of the variable without altering the original variable. Think of it this way. We will go back to our analogy of Ingrid painting a room for us. Instead of Ingrid taking the sandpaper, paint, and brushes from us that we want her to use, she talks to us on the phone to find out exactly what type and color of the paint we want to use, what kind of sandpaper, coarse or fine, as well as the type and size of brush. Then she buys her own exact copies of what we would have given her. We keep our brushes, sandpaper, and paint, and she uses the ones she bought. She copied everything we provided and used her own stuff. The only advantage of her buying her own stuff is that maybe she didn't have to carry our stuff over to the house. She just called us on the phone to check all the parameters, the required materials for the task. She copied everything we provided and used her own stuff. The only advantage of her buying her own stuff is that maybe she didn't have to carry our stuff over to the house. She just called us on the phone to check all the parameters, the required materials for the task. Value, copy, parameters behave the same way. They get all the values of the original variables, but they make their own copies of those variables for the function with the exact same values inside of them. See Figure 8.7. Figure 8.7. A conversation is shown between a main function and a function called alpha. Alpha does not want to be responsible for the main variables x and y, so it generates its own copies m and n of those variables. Main x16 y3. Hello, Alpha. Are you there? I am sending two integers called x and y. They contain 16 and 3 respectively. Alpha, M16, and 3. Okay, hold on to your variables, x and y. I'll make my own copies called m and n, and I'll put 16 and 3 inside them. Note: a function can do anything to these value parameters, since the original variables on the main will not be touched. This aspect is one of the main reasons that programmers use value parameters. Variable reference parameters. Variable parameters, also called reference parameters, are the second type of parameter. Here the parameters do not create new copies of the original variables, but instead refer back to the original variables. In a sense, the function has full access to the original variables used in the main function. The reason these parameters are called variable is because the word variable in English usage means changeable. A variable parameter has the power to change or alter an original variable back in the main function. The intention of the programmer when she uses a variable parameter is that she wants to let the function manipulate the original variable. The function works on that variable and alters it. See Figure 8.8. Figure 8.8. A main function is shown with its own variables, a and b, and their values. Another function, beta, is shown affecting the values in those variables. Beta doubles as beta doubles a's values and makes b's value drop by 1. Since a started out as 6, it ends up being 12. Since b started out as 23, it ends up being 22. Let's look at the figure. Main. Calling beta and sending in a and b. A is 6, it becomes 12. B is 23, it becomes 22. Beta. Beta changes a to twice its value. Beta makes b go down by 1. Note: with the variable parameter, the function gets its hands on the original variable and not a copy of it. This aspect of parameter passing can be useful if the variable takes up a lot of memory and you do not want to waste more memory by generating a copy of it for the function. You decide to use the original. The reason it is called a reference parameter is because the parameter refers back to the original variable, not a copy of it. A reference book is a useful comparison because in a reference library, you cannot walk off with this book or take it back to your own room. You can only look at it there and at the library. The difference with a variable parameter is that it can do whatever it wants to at the original variable, including change its value from inside the function. In our comparison with the reference book, the variable parameter has more privileges than you do. When you use a reference book, You cannot write in it or alter it, while a variable parameter can do whatever it wants to the variable. While a variable parameter can do whatever it wants to the variable it references, the variables in the main. The symbol for a variable reference parameter. Variable parameters are designed by a symbol used in front of the name of the parameter in the parameter list of the function heading. In C++, the ampersand is the symbol used. The symbol ampersand is the only way to indicate that the parameter will refer back to an original variable in the main rather than generate a copy of that original variable. Example, int, return type, alpha, function name, int and x, int ampersand x, int ampersand y, variable type with reference symbol and parameter name. Note, if there is no symbol in front of a parameter name, then the parameter is a value parameter, and it will be a copy of an original variable. How to call a function. When you call a function from the main function, you direct the compiler to go to the function, bringing with it any variables you are sending into the function. When you write a call, you use the syntax of the function heading as a guide. For example, if a function heading has a return type and a parameter list containing two variables, it might look like this: double, find average, int first num, second num. A function call will look exactly like the heading without any of the variable types mentioned. Let's practice developing the syntax for a call, the command to get the compiler to leave where it is and go to a function. We'll do this in stages, since there is a lot of detail in this process. Where the calling begins inside the main function. The first part of the call is to use the function name, find average. The next step is to follow the restrictions of the parameter list by examining the parameters that find average has. That is, we need two integers from the main to match those in the parameter list. Find average, an integer, an integer. But wait, now comes the tricky part. First num and second num are actually variables that belong to the function find average, because those were the names used in the heading. They do not belong to the main function, so the main needs to have its own variables whose values will be passed into the find average function. Let's declare some variables of the exact same type given in the parameter list. We need two integers. Let's declare them and assign them values. Int x, y, x is equal to y, y is equal to 7. Now we can insert them into the call itself. We're almost done. Int x, y, x is equal to y, x is equal to 5, y is equal to 7. Find average x, y. This is an incomplete call. Remember that find average, which uses value parameters, there is no symbol. We'll copy the values of x and y, but ultimately leave those variables alone. Find average looks at x and y and generates copies of those variables and calls them by its own designated names of first num and second num. The last stage of developing a call is to handle the return type. When find average is done with its work, it will send back a variable of type double to the main function which called it. So we need to be ready to catch what it sends back. We declare a double variable and use it in an assignment statement like this. Int x, y. Double average. X is equal to 5, y is equal to 7. Average. Find average x, y. The call is now complete. Now we can analyze the syntax of a correct call. Average, return type, equals assignment operator, find average, function name, x, y, variables from the main that will be copied by function. The receiving end. Inside the called function, find average. Once the call has been made, the compiler enters the function, but now is doing its work. That is, executing code which the copies of the variables and their new names here, first num and second num. Double. Find average int first num second num. Open brace. Developing an average for two things. Add the two variables like this. First num plus second num. Then divide that answer by 2 for the average. First num plus second num divided by 2. I need parentheses to do addition first, closing brace. We're almost done. We just need to handle the part about returning values. We use a return statement as the last part of the function. When the function has finished its work, it needs to return a value that is of the double type, as specified in the heading. Remember when Jack returned the DVD player when he had finished repairing it? We do the same in a function. We return the value. Before we do that, we will declare a variable of the double type. Double. Find average int first num second num. Opening brace. Double the average. The average equals first num plus second num. I did the same thing I did in the main. I assigned the results to the variable. Now I can return it. Return the average. Closing brace. In order to avoid confusion about the different variable names, let's look at it this way. Imagine two rooms, one called the main room and the other called the find average room. Each room has its own variables. Each room has its own variables. These variables can't leave the room they're in. They are only recognized in their respective rooms. When the main makes a call to a function, it uses its own variables to do this. On the other end, the function receives the call and catches these variables with its own variables of the exact same type. Variables in calls must match variables in heading type for type. See Figure 8.9. Figure 8.9. Variables as they appear in their own room. Each variable has its own box to show that it contains a certain value. In this example, we will send the numbers 4 and 3 into the function and get back the value 3.5 after the average of 4 and 3 is computed. Note the direction of the arrows to show which variable sent its value back to the other. So main and find average. X4, first num 4. Y3, second num 3. The average from find average 3.5 goes to the average 3.5 in the main. Okay. Each variable is only recognized by its own room, so we need to have different names for the call and the heading. The main room, the find average room. X, Y, first num, second num. Average, the average. Note, using functions in your program is a great idea because it allows you to reuse the page of code without rewriting it. Every time you want to compute an average, for example, you just have to call the function that computes averages instead of writing that code again. Reusability is how describing the kind of code that contains functions for repetitive tasks. Summary. In this chapter, we covered the topic of functions. Functions provide a way of organizing code in a program so that any reader of the program will be able to understand it easily. Calling a function to do a task like printing a chart whenever you need it done is easier than repeating a block of code in your program. Your program will be shorter and more organized through the use of functions. I gave some examples of different kinds of functions, both those that produce a value as well as those that execute a task, like printing some message repeatedly. Functions have very specific syntax, grammar, requirements. You need to write a function heading that includes a function name, parameter list, and a return variable type if necessary. Parameters are the names of variables that the function needs from the main function, the calling place of the program. There are two types of parameters: value, also called copy parameters, and variable, also known as reference parameters. The variable parameters are designated by an ampersand symbol in the front of them. When you call a function, it is important to match the variables from the main type for types. When you call a function, it is important to match the variable from the main type for type with those in the function heading. It is also a good practice to use different variables names in the function heading so there will be no confusion between the variables used in the call in the main function and those used in the heading of the function.